Hello friends, and welcome to this lesson on lipids. This is going to give you a general idea of what a lipid is, a few different examples, and again the general structure of a fatty acid, which is a part of a lipid. So let's get straight into it. So some examples of lipids we all know: fats, oils, and waxes. Things like butter as well form under lipids. And so let's do a few examples with a few sort of basic diagrams. So this is kind of what a fatty acid looks like. Another example would be something like a phospholipid. Phospholipid. And this is just to sort of help you make notes. A triglyceride kind of looks like this. This is a triglyceride. So triglycerides. The main basic structure that you need to learn is of the fatty acid. So let's quickly go and get that out the way. You get two different types of fatty acids that you need to know. The first one is called a saturated fatty acid. I'm going to explain what saturated means after I've done the diagram. So to start with a fatty acid, you start with the one end. Let me just get some space here. Start with the one end, which has a carbon joined to a double bond oxygen and an OH group. Can you remember what that is called? It's called a carboxyl group. And then you get your long chain of carbons. So generally speaking, when you have a lipid, you're going to have a lot more carbon than you're going to have oxygen. If you remember with something like glucose, C6H12O6, you can see the oxygens and carbons are quite similar. In a fatty acid, there's far more carbons than there is oxygens. So that's something that we should highlight right now. Contains less oxygen atoms, or less oxygen than carbon. This is a defining characteristic of a lipid, and so I'm going to make that sort of jump out the page right now. I suggest doing the same if you are making notes. Let's get a bigger highlighter. No, it's jumping. Oh, it's popping. Okay, cool. So, general structure. You start with the one end. It's got a carboxyl group, and then you're going to have at least 10 to 14 carbons. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put in 10 here, and then you simply add hydrogens all the way. Okay? Now you can see there is no space for anything else here. Think of a sponge. You soak up some water. There's no more water that can get into that sponge. We call that sponge saturated. And it's the same with a saturated fatty acid. It's full of bonds that join up to hydrogen. With an unsaturated fatty acid, one of these bonds between a carbon after the carboxylic group will have a double bond carbon, which means that double bond can break and you can add certain things to it. As soon as you see something with a double bond in the long chain, it's called an unsaturated fatty acid. That's the basics. We can obviously dive deeper into that theory, dive deeper into that knowledge, but it gets a bit too chemistry heavy. So I'm just going to keep it nice and simple. I'm going to draw an unsaturated fatty acid, OH, and now I'm going to just link up some carbons, and somewhere along the line, maybe over here, I'm going to draw a double bond. The double bond does cause the molecule to slightly bend, so just draw a nice little bend, or just be aware that it kind of looks like it's bending when they give you a diagram. So this is unsaturated. Why? I can see a double bond in the long chain, and of course now we add all our hydrogens. Now notice carbon can make 4 bonds. So be careful when you get to the carbon that has the double bond, because this carbon has that 1 and then the double over here. So it's got a potential to have 1 more hydrogen, not 2, because that would not apply to the rule of carbon having 4 bonds. Same with this one, so it only has 1, and then these 2 will have 2. And the end has 3 H's. So that is an unsaturated fatty acid. You need to be able to recognize, if I've given you this diagram in a test or an exam, you can immediately say, okay, cool, that's a fatty acid, that's a lipid over there. Okay, great. Now, let's go on to talk about the other different types. This is the classic fatty acid, and this can form part of other molecules as well. So for example, triglycerides have a glycerol molecule. So this molecule over here is a glycerol molecule, and attached to that will be 3 fatty acids. So you kind of got this long chain here, but it's orientated vertically. And so that is a fatty acid, that's a triglyceride, phospholipid. Let's go in and look at some more detail on the phospholipids specifically. Let's have a look at phospholipids. This is sort of number 3. Also need to be able to recognize a phospholipid. You don't need to be able to draw it, but just know that the word phospho is there, which means it has a phosphate group. It's going to have the element phosphorus. It's going to have a P in it. So let's quickly draw that. There is your phosphate group. Soon as you see that, okay, of course, it's going to have a whole chain coming off of it as well. So you've got this CH. I'm not going to draw the whole thing, but kind of looks like this. I'll show you a better diagram of this, because I'm not 100% sure if I've drawn this perfectly correctly. Even I don't know how to draw a phospholipid from memory. I have to look at my notes here. Okay, so here you got the 2 fatty acids that you can see. I'm just going to draw them like this, knowing that each one of these is a carbon, each link is a carbon that's going to have its hydrogens coming off of it as well, but I'm just drawing sort of condensed version of that. Okay, so immediately I look at the structure, I go, what is it? It's a phospholipid. Why? Because I can see that phosphate group, I can see the phosphorus atom. When phosphorus is joined up to 3 oxygens, we call it a phosphate. Okay, that's phospholipids. Let's just quickly hit the notes on lipids. So lipid molecules contain much less oxygen than carbon, or the other way to think of that, it's they have more carbon than oxygen. We've got saturated. I will share these notes with you as well. All carbon bonds with single bonds. So you can see again all the single bonds. This is a saturated fatty acid. Things like butter and lard are saturated fatty acids. Then we've got unsaturated. They have at least 1 double bond. Let's go back to my diagram over here. That's a unsaturated fatty acid, and these are things like olive oil. We've got the triglycerides. As I said, it's got this glycerol molecule that's joined to 3 fatty acids, and it's the main constituent in body fat in humans. And so what is fat for? We can have a look at the bottom of these notes. It's good for buoyancy for animals like this otter. I think that's an otter. And so it gives you the ability to be less dense than water, so you can float around. It's an electrical insulation around our nerve endings. It helps us conduct impulses. For example, if you want to lift something up, you need to send a message to your muscle that goes along a nerve, and to insulate that nerve, we use lipids. It's good for energy storage. We can use lipids for energy. It's good for membranes. Phospholipids make up a lot of membranes, and this can help with various different things. Cholesterol, let's go and look at cholesterol. It's one of the molecules we need to be able to recognize, so let's do that now. Cholesterol. Okay, cholesterol has these 4 rings, these hexagonal rings. So 1, 2, I've drawn a terrible hexagon. Let's draw it like this. Okay, there's one ring, and then it's joined up to another ring. So how to recognize that this is cholesterol, I'll show you in a second. The first thing is important, that it's got these rings. The last one is a pentagon. Let me just double check that. Cholesterol, yeah, no, it's 1, 2, 3, 4, 5. Yeah, the last one is that little pentagon, and then the cholesterol molecule has this chain coming off of it. So you've got this chain of carbons coming off for a cholesterol molecule, and the end of it ends in this C sort of triangle structure, which you can see over there. Now, a steroid, it looks very similar. It has four rings arranged, but it's got this OH group and this double bond OH at the end. So this is cholesterol, this is a steroid. You need to be able to recognize these molecules if I give them to you in a test or an exam. That's pretty much lipids in terms of what the general structure of a fatty acid looks like, the general structure of a phospholipid, and cholesterol and steroids, and then the different functions of lipids. I hope it's been helpful, and see you next time when we are into the next lesson.